In this example, we have a car that travels at an average velocity of 25 kilometers per hour for 50 kilometers. It rests for half an hour, then travels at 50 kilometers per hour for another 100 kilometers, and then it travels backwards at 10 kilometers per hour for 0.1 hours. The question is, what is the magnitude of the average velocity of the car over the full trip? Assume the car moves along a straight line. Okay, so again, in this particular question, we have several segments of the motion. They are asking us for the average velocity of the car over the full trip. Average velocity is in magnitude displacement over time. So to be able to find the average velocity, I need to find the displacement and I need to find the time. Okay, the time and the displacement are going to be calculated by considering each of the four segments. So for segment 1, the car moves at 25 kilometers per hour. That's the velocity, average velocity during that segment. And the displacement during that segment is 50 kilometers. So we know D1 is 50 kilometers. T1, the time for that segment, is going to be the displacement during that segment over the velocity during that segment. So this is the magnitude of the displacement over the magnitude of the velocity. So in this case, that's going to be 50 kilometers per hour. 50 kilometers over 25 kilometers per hour. So that gives us T1 being 2 hours. Okay, now for T2, for segment 2, here is segment 2. It rests for 0.5 hours. Rests meaning our displacement is equal to 0. My T2 is given. It's 0.5 hours. So we are covered with that one. Now the next segment, it is 50 kilometers per hour for 100 kilometers. So using the same procedure, so D3 is 100 kilometers, and then T3, that's going to be D3 over V3, so 100 kilometers over 50 kilometers per hour. So in this case, that's going to be equal to 2 hours again. The last step, they tell us, backward at 10 kilometers per hour for 0.1 hours. So we have to pay attention to the word backwards here. Backwards meaning that my displacement is negative. My velocity is negative. When we say 10 kilometers per hour, it's actually minus 10 kilometers per hour. The minus accounts for the backward direction. We are given the time. So in this case, T4 is given 0.1 hours. Now, for the displacement, D4, it's going to be V4 in magnitude times T4. So that's going to be equal to 10 kilometers per hour in magnitude times 0.1 hours. Okay, let me change the color of the pen. Here, 0.1 hours. Okay, so that gives us 10 times 0.1 is 1, so D4 is 1 kilometers. Now that's the magnitude of D4. Magnitude of D4 is 1 kilometer. D4 is actually since it's in the opposite direction, minus 1 kilometers. Now my overall displacement is going to be d1 plus d2 plus d3 plus d4. So that's going to be, I'm going to write it here on the top, just trying to find space. So that's going to be here, 50 kilometers plus 0 plus 100 kilometers minus 1 kilometer. So it is 149 kilometers. That's my overall displacement. Okay, let me erase in the bottom here a little bit so I can write. Going back to pen. So my T is T1 plus T2 plus T3 plus T4. So in this case, that's going to be equal to 2 hours plus 0.5 hours plus 2 hours plus 0.1 hours. 2 to 4, it's 4.6 hours. Going back to eraser to find space. So my overall average velocity is going to be displacement over time. So in magnitudes here, it's going to be 149 kilometers over 4.6 hours. So that comes out to be 32 kilometers per hour. That's my average velocity.